Okay, welcome back to Mr. Hassan's Maths channel. I am now answering question number 10 from the International A-Level Edexcel Pure Mathematics P1 January 2020 paper. And this question here is about curve sketching and cubic curves and also transformations. So part A is asking us to sketch the curve of y equals f of x, where f of x equals 4x minus 3 x times x minus 5 squared. That's called C1. And we're going to sketch C1 showing the coordinates of any point where the curve touches or crosses the coordinate axes. Okay, so now, when we want to sketch a curve, as they've pointed out here, you have to show the points where it crosses the coordinate axes, the x and y axes. And you have to also, of course, have the correct shape of the curve and how it looks. Now, this is a cubic curve, okay? This is a cubic curve because when you expand it, which you don't actually need to do, when you expand it, you'll end up with an x cubed. It'll be 4x cubed. All right, will be the x cubed term. So it's a cubic curve, okay, because the highest power is x cubed. All right? Of course, there's going to be x squared and x terms in there, but the highest power is x cubed. That's why it's called a cubic curve. And we can see the coefficient of x cubed, the leading coefficient is called the coefficient of x cubed. The coefficient of x cubed is going to be, you're going to have 4x times x squared, which is 4x squared. Okay, it's 4x squared. Therefore, it's a positive coefficient, 4x cubed. Sorry, I want to say x squared. 4x cubed. It's a positive coefficient. So now, a cubic curve can have either a shape, which I myself call rise and rise, or it can have a shape which I call fall and fall. Okay, if it's a positive coefficient of x cubed, it's like rise and rise. Okay, and if it's a negative coefficient of x cubed, it's like fall and fall. Okay, so basically we can see that this is a positive coefficient of x cubed, so it's going to be a rise and rise and not a fall and fall. Okay, basically the mathematical term for this is as x gets larger, y gets larger, as x gets smaller, y also gets smaller. Whereas in this case, as x gets larger, y gets smaller, and as x gets smaller, y gets larger. That's like the mathematical way of thinking about this. I call it rise and rise and fall and fall. Rise and rise is when you have a positive x cubed. Fall and fall is when you have a negative x cubed. So that's one thing to note. The shape of the curve will be something in that form. Okay. Secondly, we need to find the intercepts. So let's start with the y-intercept. The y-intercept is when x equals 0. When x equals 0, you have y equals 4 times 0, which is 0 minus 3. That's minus 3 times 0 minus 5, which is minus 5, and that's going to be squared. Now don't forget that you have to square before you multiply. So it's minus 3 times minus 5 squared, which is 25. So it's actually negative 75. So it's going to cross the y-axis at 0 and negative 75. So we know where it crosses the y-axis. Now we've got to find the x-intercepts. That's when y equals 0. Now, conveniently, it's already factorized for us, which is going to be the case in these type of questions in P1. Okay, not so in P2. You have to know how to factorize cubic expressions where there's a constant as well as just x terms. So now 4x minus 3 times x minus 5 squared, it's already factorized. There's no need for us to expand it. It's factorized. So we got a product of these factors equal to 0. There's actually 3 factors here. There's actually 4x minus 3, x minus 5, and x minus 5 again. That's actually what you have here. There's 3 roots, but one of them is a repeated root. So these 2 roots are like one repeated root, and that's very important in this particular problem here. Okay, so you have either 4x minus 3 equals 0, in which case x is equal to 0.75, 3/4, or x equals 5, x minus 5 equals 0, so x equals 5, and this is repeated. Now, it's really important for you to understand that it's a repeated root. Whenever you see something like this on one of these cubic curves or any type of curve, you'll notice something very special happening on the shape of the curve. Now, so we have all the information we need to sketch the curve. So I'm going to draw my y-axis, I'm going to draw my x-axis, Okay. Maybe I need to give myself a bit more space here. Okay, so we know that it passes through. The x coordinates it passes through are 0.75, 0 and 5, 0, and I'm going to put an asterisk next to this to show that it's a repeated root. This is a repeated root. Okay, so you have your y-axis, you have your x-axis, you have your origin marked, and you have the points where it crosses. So it crosses at negative 75, so I'll put that here. And it's also going to cross at 3/4, which is 0.75, and at 5. But at 5, it won't cross. At 5, it will, because it's a repeated root, it will turn on the curve at that point. So basically, when there's a single root like 0.75, it's going to cut through the axis at that point. I'm not going to put these points until afterwards because I kind of fiddle it at the end. But basically, you know that it's going to come up and cut through here because it's going to have this shape. All right? So it's going to cut through at the point 0.75, okay? Wherever that is, somewhere over here. I'm going to, when I sketch it, I'll become clearer according to my sketch. And at x equals 5, it's not going to cut through the curve. It's going to turn on the curve. Whenever you have a repeated root, you have something, a squared bracket like that, it's not going to cut through the curve at the point. It's going to come and touch the curve and then go away from the curve. It won't cut through it. It will turn on it. So this is going to come from below because it's got this shape. It's going to cut through at the first point. And at the second point, it's going to turn. So I'm going to draw it nice. Oops. I wanted to draw it nicely. Let me do it again. So it's going to come up. It's going to cut through at 0.75. It's going to turn somewhere over there. And it's going to go down. And it's going to turn on x equals 5. And it's going to go up like this. Have some sort of shape like that. It's not bad. Okay, I'm not too good at these. But this is 0.75. And this is 5. I like to put them points in afterwards, after I've drawn, so that it looks a bit better. Okay, so there we have. Why did I put x there? Sorry about that. That's 5. X equals 5. Okay, so that's 5. So it says, it tells us to sketch, showing the coordinates of any point where the curve touches or crosses the coordinate axes. Now it's better to, I mean, it's fine if you leave it like this, but because it says coordinates in the question, coordinates means like the x and y coordinates. It's pretty obvious that those are 0.750 and 50, but it might just be better to write it in coordinate form, so 0 and negative 75. And you've got all of the coordinates of the points. You've got it in the right shape, and that's fine. That's perfectly fine. Add your graph. You're going to put arrow here if you want, an arrow there to show that it's continuous. It continues on in that direction and that direction. That is perfectly fine as your shape of your curve. It's a rise and rise curve, and it also cuts through at 0.75 and it turns at 5, so it must be something like this. So there we have that curve drawn, and that's perfectly good. Now it says, hence or otherwise, find the values of x for which f(x) equals 0. Okay, so I'm going to show you in both ways. I'm going to show you the way that uses hence, meaning using your sketch, and I'm also going to show you in another way that uses algebraic kind of a method. Okay, so I'll first show you the hence way. So we're going to deal first with the hence method. Okay, hence, otherwise we'll deal with hence. Normally hence is the easier way of doing things. Okay, and if the question said hence only, then there would be no marks or maybe very few marks for doing it in any other way. But when it says hence or otherwise, you've got the choice of doing it whichever way you prefer. Now, I'm going to show you using the sketch and using f of x equals a quarter, f of a quarter x, equals 0. So what does this mean? F of a quarter x equals 0. All right, so it means this new function, which is y equals f of a quarter x, okay, we want to know when this touches the x-axis, because when f of a function equals 0, okay, when a function equals 0, when y equals 0, that's where its roots are, where it touches the x-axis. So this is a transformation. This is a transformation of y equals f of x. Okay, so f of a quarter x is the transformation in such a way that it's called a horizontal stretch. A horizontal stretch of factor 4. Okay, so the curve has been stretched by a factor of 4. Okay, so whenever something is changed inside the function, it affects the horizontal kind of movement. Okay, so if it's multiplied inside the function, it's a stretch, and the stretch factor is the reciprocal of the number it's multiplied by. So this is going to be a horizontal stretch of factor 4. So that means only the x coordinates are affected and the y coordinates are unchanged. So what this means is the roots of the original function. So you have the roots of y equals f of x. Okay, the roots would be, let me do it this way. Okay, so if you have y equals f of x, okay, the roots are going to be, as we saw already, the roots are 0.75, so that's like 3/4, and 0. And the other root is, as we saw, 5 and 0. And that's the repeated root. Now, for y equals f a quarter x, the roots are going to be, okay, for this one, you're going to multiply the x coordinate by 4 and leave the y coordinate as it is. So the roots of this are going to be 3/4 times 4, which is 3, and the y coordinate will stay 0. And here you're multiplying by 4, the x coordinate. So 5 times 4, which is 20, and 0 stays as it is. Okay, so the answer for this is the values of f of x for which f of a quarter x equals 0 are 5, 0, and 20, 0. Those are the answers for that question. These are the roots of the new equation f equals a quarter x. Okay, 5, 0. Sorry, not 5, 0. What am I doing? That's the old root. 3, 0, and 20, 0. I'll write it separately here. 3, 0, and 20, 0 are our new roots. Those are the roots of, this is when f of a quarter x is equal to 0. Okay, so basically what's going to happen is this root is going to get, multiplied by 4. And this root's going to get multiplied by 4. The whole function will stretch outwards. Okay, so this will be 4 times its distance from the x-axis, and this will be 4 times its distance from the x-axis. So 4 times 3/4 is 3, and 4 times 5 is 20. So the new curve would look like that. Okay, so that's where we got that from. And then it says find the value of the constant p such that the curve with the equation y equals f of x plus p passes through the origin. So I'm going to show you that up here, because I'll just do this up here, part 2, because you can see the curve here. Basically, it's saying y equals f of x plus p passes through the origin. Now, for this to pass through the origin, first of all, this represents a translation. Okay, this represents a translation. When you add something to the whole function, it only affects the y coordinates. So this is a translation of 0, p. Okay, so this is always going to be vertical, either up if p is positive and or down if p is negative. So it's a translation of 0, p, okay, going up or down. Now, if this passes through the origin, and the only things that can change are the y values of every point, it's this point that's going to be going through the origin if it's transformed. So the whole of this curve is going to be lifted up like that until it passes through the origin. So basically, it's a vertical translation, and it has to go from 0, -75, up all the way through the origin. So it has to move up by 75 units for it to go, for that point to go from there to there. It has to move upwards by 75 units. Okay, so it has to go from there to there. That's 75 units. So that means P must equal 75. So we worked that out, positive 75. We've worked that out. That's part 2 of the question. We worked that out from the translation of the curve. So we used the sketch of the curve to calculate these 2 answers. Okay, so the values of x for which this is equal to 0 are 3, 0, and 20, 0. And for this, it's p equals 75. And there we have the answers for part B. Okay, now I'm going to show you part B in another way. I'm going to show you part B in another way, otherwise, because it says hence or otherwise. I personally would have used the hence method, but you can also do this algebraically using the equation of y equals f of x that we're given. So for part 1, we're told to find the values of x for which f of a quarter x equals 0. Okay, so what we're going to do is we understand that f of a quarter x is when you replace the x with a quarter x. It's like if you say f2, it means you replace the x with 2. Now f of a quarter x means take the x and replace it with a quarter x. So you're going to have 4 times, instead of x, I'm going to put a quarter x minus 3 times, and instead of x, I'll put a quarter x, so I'll have a quarter x minus 5 all squared. Now I'm not going to expand this. I'm just going to simplify what's in here. This is going to give you 4 times a quarter, which is 1, so it's x minus 3 times a quarter x minus 5 squared. Now, we want to find where this is equal to 0. Okay, so we have to solve the equation x minus 3 times a quarter x minus 5 equals 0. Okay, when f quarter x equals 0. So we can solve this. You say, okay, x minus 3 equals 0, so x equals 3. And a quarter x minus 5 equals 0, so a quarter x equals 5. So we can say x equals 20 by multiplying both sides by 4. So we have our 2 answers there done purely algebraically without even looking at the sketch. And part 2, I'm just going to do this here, although I should really do it down there just to save some space. Part 2, it tells us to find the value of the constant p such that the curve with the equation y equals f of x plus p passes the origin. So the original equation is here, f of x. So we're going to now write down what the equation f of x, okay, plus p is. Y equals f of x plus p. So that will be y equals f of x, which is the original function, 4x minus 3 times x minus 5 squared plus p. And we want to know when this passes through the origin. We want to find the value of p when this passes through the origin. So it passes through the origin when x is 0 and y is 0. So if we substitute x is 0 and y is 0, we should be able to find what p is, because that is the point, the origin, okay, which satisfies the equation of this curve, okay, as it passes through it. So 0 equals, now instead of 4 times, this will be 4 times 0, which is 0, so minus 3. This will be 0 minus 5, which is minus 5 squared, plus p. Again, don't forget that we have to square before we multiply. So it's minus 3 times 25, which is minus 75, plus p. Therefore, we can say p is equal to 75. And there's the answer to part 2, done purely algebraically without looking at the sketch. So we answered this question using the otherwise method. Okay, so both ways are perfectly acceptable, although I prefer the sketching method. Normally the hence method is a simpler one. Now, a second curve, C2, has equation y equals g of x, where g of x is equal to fx plus 1. Find in its simplest form g of x. You may leave your answer in factorized form. So they want you to do some algebra here, because even if you use the sketching method, you have to understand what we just did up there in this question. So basically what they're saying is find the equation of g of x in factorized form, you don't need to expand it, and then hence or otherwise find the y-intercept of the of curve 2. So basically the same thing that we did there, except this time we have to replace. So we can say g of x is equal to f of x plus 1. So let's just write it that way. So we know that g of x is f of x plus 1 inside the function, not f of x plus 1, but f x plus 1 inside the function. So what that means is you replace the x in the original function with x plus 1. So instead of 4 times x, it's going to be 4 times x plus 1 minus 3. You replace the x here with x plus 1, and also in the other bracket you must place the x with x plus 1. So you'll have x plus 1 minus 5, and this bracket is squared. So this is going to give you 4x plus 4 minus 3. So that's 4x minus plus 1. Okay, 4x plus 4 minus 3 is 4x plus 1. X plus 1 minus 5, which is x minus 4, sorry. X minus 4 squared. Okay, so that is a new function. That is a function g of x, which is f of x plus 1. So this is the equation of this function in simplified form. Okay, so that's the answer for part 1, C part 1. Now it's asking us to do C part 2. It says, hence or otherwise, find the y-intercept of curve C. So now we could also use the curve on the other side of the page. I'll show you how to do that first. So it says hence or otherwise. Okay, so f of x plus 1. Okay, is where you shift everything 1 unit to the left. Okay, now that's going to be difficult here actually. I don't think the hence means that in this case. No, because that will be a bit difficult to work out the y-intercept from that. But hence or otherwise find the y-intercept of curve C. So basically what we can do here is we can find the y-intercept when x equals 0. So we can substitute x equals 0 into this equation. So when x equals 0, we'll have y equals 4 times 0, which is 4, plus 1, that's 1. And you have 0 times minus 4, that's minus 4 squared. So that's going to give you 1 times 16, which is 16, because minus 4 squared is positive 16. So it's 16. So the y-intercept is equal to 16. Okay, they didn't say the coordinates of the y-intercept, so you don't write 0, 16, just write 16. Okay, so that is the answer to question C part 2. Okay, yeah, so that's, I guess, the otherwise part might be if you expand this all, but let's have a look. We know that the y-intercept of the other curve was minus 75. Let's have a look. And this went through a quarter, 75. I think that's about the only way of doing this question. What's the otherwise about? Let me just think for a second. Okay, I guess the otherwise part here is something maybe a bit more complicated, which I wouldn't really use at all, but I'm guessing what it would be is because f of x plus 1 is a translation of 1 unit to the left. Okay, so if you worked out what the value of y was when x equals 1 in this original function, which is y equals f of x, if you put y equals 1 into here, okay, let's see what it will give you. You're going to have 4 times 1, which is 4 minus 3, which is 1, and you have 1 minus 4, so you have 1 minus 4 squared. That's going to give you 16. Okay, yeah, so this will go through the point 116. When x equals 1, y equals 16. And as this is a translation, fx plus 1 is a translation of 1 unit to the left. So that means this function is going to go through the point 0, 16, because it's moved 1 space to the left. So the x coordinates are shifted 1 unit to the left. So that means this is going to be the y-intercept. So y-intercept will be 16. So I guess that's what they mean by otherwise here, just thinking about it for a little while. But I don't think I would have used that, although that would be a valid way. This seems a lot easier, just putting x equals 0 into the new equation, which you had to find anyway, and then finding out what g of x. I guess the otherwise form would be to find out where does the original function, what happens when x equals 1 in the original function, and then you know that fx plus 1 is when the x value is reduced by 1, so that point will then become the y-intercept in the new equation. But I think that's a bit of hassle. So there we have it, the answer to question number 10, part A, B, and C from the January 2020 paper. I hope you understood everything fine. This is the playlist, what will show up in a minute here. There's a playlist for the rest of the questions on this paper. Here we have the playlist. One of these places will be the playlist for other questions on this topic of sketching graphs. There will be a card with some other P1 papers in the top, and you can subscribe to my channel by clicking on the icon that appears somewhere in the middle here. Thank you for watching, and hope to see you again soon.